There. Okay, so we're going to do a talk on test-driven development. That was what we're all expecting?
Pretty much, yep.
Good. What do you know about test-driven development?
Test.
Good, yes, test. Excellent. Has anybody done it?
Very
I can
small.
see your hand. So you can raise your hand. If you've done test-driven development, raise your hand. I can see you all. Oh, look at that guy. Got a guy. One guy there. Okay, so test-driven development. What the devil is it? This is an old discipline. It's been around now for probably 15 years. It's actually older than that, but it really became popular about 15 years ago. When the Agile movement started. It is a discipline. And like all disciplines, it is arbitrary. There are parts of it that you may feel make no sense. That's okay. It's just an arbitrary discipline. So, for example, surgeons will wash their hands before they operate. And they have a discipline for this. They will go into the operating room, the scrub room, and they'll get a brush and they will do 10 strokes across the finger, right? And then 10 strokes across the top of the finger, and then 10 strokes across the side, and then 10 strokes across the face, and 10 strokes across the nail, and then they do the next finger. Is 10 the right number? I don't know. Would 8 suffice? Maybe. Should it be 12? Maybe. It doesn't matter. It's arbitrary. It's a discipline, a ritual. So you can expect to feel that way about test-driven development as well. It's an arbitrary discipline. But the thing about a discipline is that once you decide to follow it, you follow it. Whether it's arbitrary or not, it becomes something ingrained that you follow almost all the time. So what are these disciplines? What is the rule of test-driven development? So I can show it to you here. I've got a nice little slide. Can you see all that slide?
Yeah.
Everybody see it? Yep, good, okay. The 3 laws of test-driven development. I broke it down into these 3 laws a long time ago. And the first one is immediately difficult to understand. You are not allowed to write any production code unless it is to make a failing unit test pass. Now, right away, this sounds goofy, right? Because what are you going to test? There's no production code written yet. You can't write the production code until you have a failing unit test, which means you have to write the unit test before you write the code. And what are you going to test if there's no code? So it makes no sense at first. But don't worry about that, because the second law is worse. The second law says you are not allowed to write more of a unit test than is sufficient to fail. And compilation failures are failures, which means that you can start out to write a unit test, but within a line or two, it's not going to compile because you're calling something that you haven't written yet. And so you'll have to stop writing the unit test. You can't finish it. And you'll have to start writing production code. And then the third law is the worst of them all. It says that you're not allowed to write more production code than is sufficient to pass the currently failing test. If you think about this, these 3 laws will lock you into a cycle that is 5 seconds long, 10 seconds long. You will know that you want to write some code, but you can't because you have to write a unit test. So you start to write the unit test, but after writing a line of it, you have to stop because it doesn't compile. So then you have to start writing production code, But after writing a line of it, you have to stop because that makes the test compile. So then you have to write another line of the unit test, but that fails. And then you have to write another line of production code, and that makes it pass. And you go back and forth between these two streams of code on a almost 5-second or 10-second cycle time. Now, if you're a programmer of any experience, that just sounds stupid. Why would you do this? It would be boring, it would be dull, it would be tedious. You would never be able to think through an if statement without interrupting yourself and writing a test halfway through it. You'd never be able to think through a while loop without interrupting yourself. In fact, you're just constantly interrupting yourself, adding a little test, little code, little test, little code. And why would you do this? Right? It makes no sense. To the normal programmer, this makes no sense. But, there had to be a but, right? But, imagine a group of people like you in a room like you have at the moment, all following these three laws. Pick one of those people. Doesn't matter who, doesn't matter when. Everything they were working on executed and passed its tests sometime in the last few minutes. Probably sometime in the last 1 minute. And it doesn't matter who you pick, and it doesn't matter when you pick them. Everything worked a minute ago. What would your life be like if a minute ago everything worked? How much debugging do you think you'd do? There's not a lot of debugging to do if everything worked a minute ago. How many of you are good at the debugger? You know the debugger. The debugger is your tool. You know all the hotkeys. You know how to step into and step over and set watch points and break points, and you can set a break point here and get to it 3 times, and then get it to another break point 6 more times, and then wait for this variable to be a 37, and then really debug. This is not a skill to be desired. You don't want to be good at the debugger. The only way you get good at the debugger is to spend a lot of time debugging. And I don't want you debugging. When you are following these 3 laws, there's hardly any reason to debug anything because everything worked a minute ago. Now, I'm not saying that you don't get bugs. You do. It's still software. It's still hard. There are still weirdo bugs that happen. But they happen much less frequently because most of the time, everything worked a minute ago. So the most common debugging technique is to hit Control-Z enough times to undo what you last did that broke something, and then to retype the line of code that broke it. There's hardly any thought process for debugging. That may make some of you a little bit anxious because you like to debug, but believe me, it's a habit you can get over pretty quickly. So I could say that following these 3 laws would shorten your debug time by half. But never mind that. That's not the issue. There's another issue. How many of you have integrated a third-party package? Oh, see, I can see your hands. Isn't that good? Yes, and you've integrated a third-party package. Where did you get the package from? Well, maybe you downloaded it from the internet, or maybe you got a DVD back in the old days. God knows what. And inside this third-party package, there's some DLLs, there's some source code, there's some jar files. There's also probably a PDF in there. And that PDF contains an ugly appendix, and that ugly appendix contains all the example code. Where's the first place you go? You don't want to read the manual, the PDF manual. Some tech writer did that. You go right to the appendix, you go right to the example code, and you read the example code because the example code will tell you the truth. When you write unit tests, according to these 3 laws, what you are writing are the example code for the whole system. The code examples for everything you're doing. You want to know how to create an object? There's a unit test that creates that object every way it can be created. You want to know how to call some API function? There is a unit test that calls that API function every way it can be called. And these unit tests are small little snippets of code. They're all independent from each other. They don't make a system, so they're not complicated. Anybody who's a programmer can read them. They're written in a language you understand. They are so formal they execute. They are absolutely unambiguous, and they cannot get out of sync with the system. They are the perfect kind of documentation for a software system. Documentation written in code that describes the system. There's an old joke. It's a joke about agile software development. And the joke goes like this. We're doing agile development. Oh, that's pretty cool. That means you must be working in pairs. Oh no, we're not working in pairs. Well, then you must be working in really short cycles. No, we don't work in short cycles. Well, then you must be writing lots and lots of tests. No, we're not doing any of that. Well, then why do you say you're doing agile development? We've decided not to write any documentation. This is the old joke that used to be told fairly frequently about agile software development, but it is a misinterpretation of what agile is about because we do write documentation. Agile software developers write documentation, but they write the best kind of documentation. They write code that documents other code. So if you follow these 3 laws, you can shorten your debug time, and you get this this stream of documentation, which is almost perfect documentation for a complicated system. But set that aside because there's something else. How many of you out there have written unit tests after the fact? Yeah, and thought you were doing test-driven development. How much fun is this? Not so much fun. Why isn't it fun? Why isn't it fun to write unit tests? And the answer to that is, it's not fun because you already know the code works. You've tested it manually. You didn't need to write the unit test to prove it to yourself. You wrote the code already, you tested it manually, you've seen it on the screen, and now, after all of that, somebody wants you to write unit tests, and that, of course, sounds like a bunch of make work. Some process weenie out there told you you had to write unit tests and guilted you into it, and so out of guilt, you write a unit test and then another one, and it's boring. And then, inevitably, you will come to the test that's hard to write. It's hard to write because the code you wrote was not written to be testable, or at least you didn't make it testable enough. It's too coupled to something. And to break that coupling and write that test would be hard. And you look at it and go, oh, man, I'm going to have to spend 20 minutes messing around with this, and then you think, but I already know it works because I tested it manually. Why do I need to write this test? And you walk away, and you leave a hole in the test script. And you know if you're doing that, everybody else is too, leaving holes in the test script. When you follow the 3 laws, something else happens. You can't write production code that's hard to test because you write the test first. And because you've written the test first, you design the production code to be testable. And another word for testable is decoupled. Simply by writing the test first, you wind up decoupling the production code in ways that you had never thought about before. You wind up with a better design. But more than that, it's fun. It's fun because the test fails, and now you get to make it pass. How many of you became programmers because you got some code to run once, and you want that feeling again? You remember long, long ago, maybe you went into a Kmart or something, and there was a Commodore 64 or a TRS-80 or some personal computer on the shelf, and you walked up to it and you wrote a basic program that printed your name 1,000,000 times, and you knew suddenly that you had the power, you were the master, the dominator of that computer. You could make it do anything. And you want that feeling again. This is what test-driven development helps you with. You get to write a test and then make it pass, and that feels good. And then you write another test and you make it pass, and that feels good, and you get that excitement again of what programming is supposed to be like. If you follow these 3 laws, you can reduce your debug time, you get great documentation, your design improves, it's fun, and none of that is why we do it. So forget all of that. Why do we do test-driven development, really? How many of you have been significantly impeded by bad code? Okay, so that's everybody. Good. Why did you write it? Now, you know it's going to slow you down. You've been significantly impeded by bad code. Everybody knows if there's bad code, it's going to slow us down. Why do we write the bad code? Well, there's lots of excuses for this, right? We write the bad code pretty much because we have to go fast. I'll leave you to deal with the logical inconsistency of writing bad code that slows you down in order to go fast. But let me ask you a different question. Why don't you clean it? When's the last time you brought some code up on your screen and you looked at it and thought, you know, I should clean this? And your very next thought is, I'm not touching it. Because you know if you touch it, you will break it. And if you break it, you will own it. And so you walk away from the code. I'm not going to be the one to clean this code because I don't want to own it. This is a fear reaction. You are reacting in fear from the code that you used to dominate. That code, that thing that you've created, no longer submits to your will. You submit to it. You have become afraid of it. It dominates you. And I submit to you this. If you are afraid to clean the code, then you never will clean it. The code will simply get worse and worse and worse over time, slowing you down, slowing everybody down, slowing the whole team down, grinding everyone into slower and slower and harder work, making the system virtually impossible to deal with. This is the only thing that can happen if you are not willing to clean the code. We are not willing to do the one thing that might improve things because we're afraid. How do we get rid of that fear? Well, imagine that you have a button, and you can push that button anytime you want to. and some lights blink and some computer noises come out of your laptop, and within a few seconds, a little green light lights up. And that green light tells you that everything works. The whole system works, and you believe it. If you've got a button you can push, and it tells you that everything works, that changes everything. Because now you will go to your laptop, you will bring code up on your screen, you will say, "Oh, this is ugly, I should clean it," and the fear is gone. You will push the button and it will turn green, and then you will make a small change to the code. You will change the name of one variable, and you'll push the button and it will go green. And then you'll say, that function there is too large. I think I'll split it into two functions. And you'll push the button and it will go green. And you'll say to yourself, well, that new function I just created, I could move it into another class. And you will push the button and it'll go red. And you'll put the function back where it was and push the button and it'll go green. And then you'll move it a different way and it'll go green. If you have that button, you're not afraid to clean the code. If you're not afraid to clean the code, you will clean the code. If you clean the code will get cleaner. And as the code gets cleaner, everybody goes faster. This is why we do test-driven development. All those other things, the debug time, the documentation, the better design, the fun, all of that stuff is extra. The real reason we do test-driven development is to get rid of the fear, to keep control over the code. Imagine how wildly irresponsible it is to be afraid of the code that you've created, to be so cowed by it that you refuse to do even the slightest little thing that might improve it. How incredibly unprofessional that is. And a suite of tests solves that problem. Oh, well, it solves the problem if you trust the suite of tests. If you don't trust the suite of tests, if the green light goes on and you look at it and you scoff at it and you say, yeah, but I know there's still problems in there, then that suite of tests is doing you no good at all. It does you no good to have a suite of tests that you don't trust. If you don't trust the suite of tests, you might as well throw them away. They're not telling you anything. It is worthless to have a suite of tests that tests half the system. It is worthless to have a suite of tests that tests 80% of the system, because there's no decision that you can make based on the outcome of those tests. You're still going to react with fear. The only way to have a suite of tests actually mean something is if you trust it, if it tests everything. And that brings us to the three laws. Because if you follow those three laws, you're going to have tests that test everything. Has anybody ever run a code coverage tool? Yeah, the guy who's raising his hand outside of the camera did. What's a good code coverage target? What percentage of the lines of code should be covered by your testers?
100%.
100%. It's the only meaningful number. Any other number is meaningless. There's no point in having a goal of 60%. Ooh, we've got 60% coverage, aren't we? Cool. There's no point in having that goal. There's no point in having a goal of 80% coverage. It doesn't tell you anything. The only thing that tells you something is 100% coverage. So that's the goal. It's a goal you can't reach, by the way. It's an asymptotic goal, but it's one of those goals that you keep on trying and trying to reach, and getting ever closer and closer, never quite ever getting there, because it's a very hard goal to achieve. But you get so close that you trust the suite of tests. But enough of the preaching. By the way, who else does this? Who else, what other profession does something like test-driven development?
Physicists?
What other profession manipulates symbols the way we do and has the issue that every one of those symbols has to be right? You write source code on a screen. Every one of the characters on that source code on that screen has to be the right character. A single character wrong can corrupt the whole system. Better yet, you could compile your code down into a binary, give me that binary on a thumb drive. I could reach into that thumb drive and find a single bit and flip that bit and make your system worthless. I can bring any systems to its knees by flipping just the right bit. We, software developers, we work in an environment where a single bit can cause a failure. Who else has that kind of problem? And the answer to that is accountants. Accountants deal with these bizarre symbols that they write down on spreadsheets. They're called numbers, these symbols. And they have to put just the right numbers in just the right places. And it has to be just perfect. And if they make a single-digit error at just the right time, then the whole company goes under and all the executives go to jail. We've seen that happen. How do accountants prevent that from happening? And the answer to that is they have a discipline. It's a discipline that was invented 500 years ago. It's called double-entry bookkeeping. They enter every transaction twice. They enter a transaction once on the liability side, once on the asset side. Those two follow separate mathematical pathways until they wind up at a subtraction on the balance sheet that must yield 0. And the way the accountants do it is they add a transaction on the liability side, they do the sums, they add the transaction on the asset side, they do the sums, they do the subtraction, they get a 0. Then they add the next transaction, assets, liability, sums, 0. Then they do the next transaction, asset, liability, sums, 0. They do not add 50 transactions to the liability side, add 50 transactions to the asset side, do the sum, do the subtraction, 37. For obvious reasons. They don't want that 37. They want to know which transaction went wrong. Test-driven development is double-entry bookkeeping. It's the same discipline, shifted slightly for software, but it's the same principle. We just say everything twice. Once on the unit test side, once on the production code side. They follow complementary execution pathways and wind up at a green light, or a 0 tests failed, or some message. In both cases, in both the accounting case and the programming case, this is a binary result, pass or fail. And that's how the accountants keep their work from imploding on them. That's how we keep our work from imploding upon us, or at least how we should be keeping our way. Do accountants have deadlines? Do managers give them impossible schedules? Are they pounding desks saying, we've got to have those spreadsheets? Of course. Under pressure, do the accountants suddenly say, well, okay, we'll do all the liabilities, we'll forget all the assets, we'll do them later? No, they go to jail if they do that. Accounting has the force of law behind it. Double-entry bookkeeping has the force of law behind it. And one day, probably not too long from now, software disciplines will have the force of law behind them, because our civilization has become far too dependent on software to allow software developers not to be regulated. That regulation is coming. I hope we can regulate ourselves before government regulates us for them instead of for us. But enough of all this, let's do a demo. I am going to show you how test-driven development works. Can you all see my screen?
Yeah.
Good. Do you see this? Prime factor test? Good, lovely. All right. What we're going to do here is we're going to write a program that calculates the prime factors of an integer. Let me tell you the history of this. My son came home from junior high school. The year was probably 2006, maybe 5, something like that. He came home from junior high school. He said, "Dad, I've got a homework problem. I have to calculate the prime factors of a bunch of integers." And I said to him, "All right, son, well, go to your bedroom, do the homework, and when you're done with it, I will have a little program written that will allow you to enter your answers, and it'll tell you if you're right or not." I wasn't going to give him the answers, but I'd give him a way to check the answers. So he went to his bedroom, he started doing his homework, and then I sat at my kitchen table, and I wrote an algorithm to calculate the prime factors of an integer. Now, how would you do this? And the answer I came up with was, well, if I had a list of prime numbers, then I could divide my candidate number by each of those primes until all the factors had been pulled out. And so I thought, well, what I have to do then is calculate a list of prime numbers, and I could use a standard algorithm for that, like the sieve of Eratosthenes. And then I'd build up this array of prime numbers, and then I would apply that to all the candidates. So that's how I thought I was going to do it. But then I said, well, let's do test-driven development here. And I had been doing test-driven development for about 5 years, so I was still kind of new at it. And I sat at my kitchen table and I said, okay, all right, well, let's just write the first test. And you can see that test right here. Assert that the factors of 1 gives us the empty list. And notice that I've implemented the factors of function to return null. I expect that this will fail. I'm going to run the test, and of course that test fails. It says, hey, I expected an empty collection, but what I got was null instead. I can fix that failure. Pretty simple thing to fix. So I'm going to return a new array list of integer. That ought to fix the test. Now the test passes. Excellent. Okay. Next test. Assert that the factors of 2 contains 2. And I will need to import my contains method. This should fail. It does. The container does not contain the 2. How do I make this pass? Well, to make it pass, I think what I can do is this. I can take this new array list and put it into a variable named factors, and I'll just return it. And then I'll put in this ugly if statement. If n is greater than 1, then factors dot add 2. And that should make my test pass. And it does. Both tests pass. Now at this point, you're probably thinking, yeah, but you just kind of hacked that in there. I mean, there's no design. Why did you make that n greater than 1? And yeah, that's exactly what I did. I just kind of hacked it in there. But watch what happens to this if statement. What happens to this if statement is fascinating. In the meantime, we need to try 3. Factors of 3. And that should contain a list with nothing but a 3 in it. This should fail. Yes, it fails. There was no 3 in the list. What was in the list was a 2. Well, that's not right. Now I need to make this pass. We're going to play a little game of golf, you and I. Golf, in test-driven development, is making the test pass with the fewest possible keystrokes. How can I make this test pass with the fewest possible keystrokes?
3. But then the other,
Change
then the
add
other
that
test
in.
will fail.
Change 2 to N.
Yeah, look at that. How clever, how devilish. A very interesting thing happened here. I took a constant and converted it into a variable. I generalized. This change was a generalization. And that brings up something interesting about test-driven development. What made the test fail was that line there, which made the tests more specific, more constraining, adding more specificity to the tests. What made the tests pass was making the production code more general. This is always going to be the case. As the tests get more specific, the production code will get more general. And we will continue this process until we have generalized a solution that passes all the tests that we can pose. The next test is a simple one. Factors of 4 contains 2 and 2. Those are the prime factors of 4. This should fail. Yep, it fails. Notice how happy I am that it failed, right? Because that's what I expected. Getting a failure that you expect is just as good as getting a green bar that you expect. Okay, now I need to make this pass. How do I make this pass? Well, it doesn't look like there's anything really clever I can do. I think what I'm going to have to do is put another if statement in here. If n mod 2 equals 0, if n is divisible by 2, then factors dot add 2. So if it's divisible by 2, I will add a 2. Now I want to reduce n by that factor, so I will say n divide equals 2. That will reduce n by the right factor. Now, let's say in the case of 4, n will come through here, and will be divisible by 2, so we'll put a 2 in the list. We will divide that 4 by 2, making n 2. We will add the second 2 to the list and return the list. That should work. Oh, but it fails. Not the 4 test. It doesn't fail this test. It's failing this test. Because if n is a 2, we find it to be divisible by 2. We put the 2 in the list. We reduce the n to a 1, and then we put a 1 in the list, and that's wrong. We never, ever want to put a 1 in the list. So let's put a little guard here. If n is greater than 1, you can add that n, but not if it's equal to 1. At this point, some of you are about to just walk out of the room because this is so bad hacking. Just awful throwing if statements in and just throwing statements in without any thought. But watch what happens next. Notice that this if statement and that if statement are the same. Isn't that interesting? And in fact, I can take this if statement right there, I can move it out of the other if statement. This will still pass. So now I have 2 consecutive if statements with the same predicate. And that should make you think of an unwound loop, a loop that somebody tore apart into a bunch of separate if statements. Keep that thought in mind, because we need to do 5. Factors of 5 are just 5. Pass or fail?
Pass.
Oh, that passes. Yeah, because 5 is prime. Okay, well, that's good. Let's try 6. That factors of 6. It contains 2 and 3. Pass or fail? Pass. Cool. Okay. Does that make any sense? Yeah, because 6 is divisible by 2, leaving a 3 left over, which we stick in the list. So that makes sense. Factors of 7 contains 7. Pass. 3 in a row. 3 in a row of pass. As hacky as this algorithm is, it's doing something right. But the next test is bound to fail. Because nothing in our code can put 3 things in the list. 8 is 2 cubed. Nope, sorry. Now, what it did find in the list was a 4, and that makes sense because probably what we did is we put a 2 in the list and then we put a 4 in the list. We're going to play another game of golf here. We're going to make this test pass in as few statements as possible, few keystrokes as possible. How can I make this pass in as few statements as possible?
Why don't you wind that loop up?
Hey, isn't that what I did? Yeah, if to while. Fascinating, right? All I did was change an if to a while, and that made the test pass. And that's a move towards generality. When you take an if and make it a while, you've made the if more general. And a while is a general form of an if. An if is a degenerate form of a while. So that was interesting. But we should do the next test. Now this must pass because there's nothing in our code that can put 2 3s in the list. This must fail. There's nothing can put 2 3s in the list. It does fail. All we put in the list was a 9. That's wrong. Okay, how do we make this pass? Well, look at here. That little loop there is a little engine that can factor out 2s. Let's copy it and paste it and change the 2s to 3s, which will make this a little engine that can factor out 3s. And that passes. But it broke a rule. We're not allowed to do what we just did. Broke 2 rules, actually. The first rule is duplicate code. We've got a duplication of code, which is always a bad idea. The second rule that we broke was this rule of making the production code more general. We didn't make the production code more general. We actually made it more specific. If we continued down this pathway, we could never finish. We'd have to add a while loop for every prime number. So I'm going to get rid of this. But maybe what we can do is take this little loop here, this little engine that factors out 2s, maybe we can put it in its own loop. In order to do that, I'm going to take this 2, and I'm going to turn that into a variable named divisor. And I'm going to take that divisor, and I'm going to take it up out of that if statement. And let's see, I'm going to take this if statement here. It turns out that if I continue to divide and divide and divide by prime factors, I will know that I'm done when n is finally equal to 1, because I will have divided out all of its factors until n is a 1. So this if statement is just the right thing. I just need to turn that into a while. Now I need to increment the divisor. Where would I do that? Well, probably here. Pass or fail? Pass. Fascinating. Okay. Well, that's interesting. You know what? This while loop cannot terminate until n is not greater than 1. Actually, it's going to be equal to 1. So this if statement no longer does anything. It really was the terminal condition of that unwound loop. That's nice. Still passes. We can probably improve on this a little bit. Like, we could make this a for loop instead of a while loop. It doesn't really need an initializer, but it does need an incrementer, and it turns out that that incrementer is just this. Don't need that semicolon anymore. Don't really need these braces anymore. I'm on a mission to destroy all braces. Ooh, that works. That's nice. And the reason I'm on a mission to destroy all braces is that I'm going to work very hard to get all my while loops and if statements down to 1 line of code. If you want to make them 2 lines of code, you can put the damn braces in. I think I can make this a for loop. And that means I can probably take that and make it the initializer of that for loop. And I'm going to need an incrementer, but I happen to have one down here. I don't need that semicolon. Really don't need that set of braces there. I think that'll still pass. Okay, well, that's interesting. Let's try the next test. Let's go for a big number. 2 times 2 times 3 times 3 times 5 times 7 times 11 times 11 times 13. That's a nice big number. The factors of that big number will be 2, 2, 3, 3, 5, 7, 11, 11, 13. Pass or fail? I believe we're done. Where did that algorithm come from? It came out of my brain. I mean, I wrote it. But I did not think through the algorithm before I wrote it. In fact, I'm not sure I've thought through the algorithm at all. Do we know why this works?
Because the test is fast.
Well, that is not good enough. Yeah. At some point, you have to kind of go, why is this working? And after a while, you realize, well, it's working because I divide through by all the 2's, and then I divide through by all the 3's, and then I divide through by 4's, but I've already taken out all the 2's. So the 4's are already gone. Then I divide through by the 5's. Then I divide through by the 6's, but by then all the 2's and 3's are gone. This is the sieve of Eratosthenes. Just twisted a little bit. Twisted to give me prime factors. This is just about the best algorithm you can get for it. You can improve it slightly by changing the loop condition there to be the square root of n rather than 1. But in any case, that algorithm got put together one tiny little test case at a time. I sat at my kitchen table in 2005 or whatever year that was. was, and I was astounded at what I had created. I thought I was going to have 30 lines of code. I thought I was going to have the sieve of Eratosthenes and then some kind of weirdo division loop. And instead I wound up with 3 lines of code. And it startled me. This is a standard example of test-driven development. It's one of the common examples I use. The little cycle you saw me go through here is very similar to what we go through when we're doing real test-driven development on really hard and complicated projects. Looks just like this. It's the only kind of thing I can demonstrate in a short talk like this. But the real thing doesn't look any different. This is what we do. We write these tests, we make them pass. We go through them one little test case at a time until everything works. Let me show you a bigger project. This is a project with about, I don't know, 70 or 80,000 lines of code. I will run the entire test suite for you. The coverage here is on the order of 95, 96%. It's hard to measure because the coverage tools can't see all the code. Some of the code executes out of process. But I believe the coverage is very high, in the high 90s. You're looking at all the JUnit tests running now. They should run in just under a minute. I do an awful lot of work in here to make sure these tests run fast. Lots of stuff is mocked out. The database is mocked out. The web server is mocked out. I do anything I can to eliminate things that are slow because I need my tests to run fast. If the tests don't run fast, you're not going to run them. So they got to run fast. And you'll see these JUnit tests will finish in about a minute. And then it'll start running a higher level set of tests, which are called acceptance tests. You'll see that happen in just a second. They take about another half minute. And that's the entire test suite. There we go. Now we're going to build the jar file. The unit tests are done. We're going to do the jar file build, and then we're going to do the acceptance tests. Here they go. Doop, 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 doop. Acceptance test. There they go. Those are the acceptance test runs. I expect that everything will pass. Again, this is a fairly large system, maybe 70 or 80,000 lines of code. It's a web-based system with a thick middleware layer and a persistence backend. Virtually every line is tested. This project has been in development since 2001. We've twisted it and tweezed it and turned it and done all kinds of stuff to it. It's remained healthy and clean throughout its lifetime because we can go in there and clean it up anytime we need to, and we do. We clean it up a lot. And this should be ending just about now. Okie dokie, 2 minutes, 5 seconds. I think the WebEx software was slowing me down just a little bit. Usually it's 1:40. But that's my test suite for a fairly large system. That is the end of my usual presentation. Are there any questions out there?
I have a question.
Certainly.
What about, a lot of us work on kind of legacy systems or systems we didn't start from scratch, and they're kind of, they're kind of big projects, but they weren't, let's say they didn't have any test cases built in mind. How do you do test-driven development in that kind of context?
You don't do test-driven development in legacy systems because they don't have any tests. So what you have to do instead is very gradually start getting some tests into the system. This test suite that you're going to be building is going to take a very long time, probably years to get right, months at least, probably years. You're not going to be able to trust it because it'll be incomplete. But every test you add will make things a little bit better. How do you add those tests? You do not start a project to put the system under test. That project will fail, and you'll wind up disgracing yourselves and disgracing the whole notion of test-driven development. What you do instead is anytime you have to touch the legacy code for any reason, you do some random act of kindness to it that allows you to begin to add a test. The first time you touch the legacy code, you might not be able to add a test. It might be too hard. The second time, you might not be able to. But you do a little bit of cleanup, just enough, not a lot of risky stuff. Change a variable name, split a function in half, maybe add an interface where it's necessary. Do something nice that moves it towards being testable. At some point in that batch of code, you can add a test. And when you add the test, that makes that little bit of code a little bit more robust. It's easier to make even more changes to it, more random acts of kindness. You can add more tests and more tests. Very, very gradually, you add tests to this system. Slowly, faithfully. I follow a simple rule. It's called the Boy Scout rule. And it's called the Boy Scout rule because the father of the Boy Scouts left this message to them after he died. He said, "Boy Scouts, leave the world better than you found it." The Boy Scouts promptly took that and changed it to leave the campground cleaner than you found it. And I took it and said, leave the code cleaner than you found it. In fact, every time you check the code in, check it in cleaner than you checked it out. Do something simple that makes it a little bit better, and then check it in. Never check it in worse. Always check it in a little better. If everybody did that, then the code base would just get better and better and better over time. Bit by bit, slowly in a legacy environment, you get the code to the point where you can add more and more tests. There are parts of the legacy that no one ever touches. No one understands, no one touches. It's been that way for years. That stuff you will never get under test. And you don't have to get it under test. It works. It's the other stuff, the stuff that you do change relatively frequently, that you manage to massage into more and more testability. There's another rule. Anytime you must add new code to the legacy, do not add the new code into the body of the legacy where it can't be tested. Add it into a brand new module that can be tested, and then wire that into the legacy. And yes, that will probably take a little bit longer, and yes, that'll make you feel uncomfortable because you're under a lot of pressure to get things done quickly, but it's the only way to solve the problem of going slow. Doesn't take that much longer. Write it in a module that is testable, write it using test-driven development, and then wire it into the legacy code. Gradually, bit by bit, you will have more and more of those kinds of modules. Gradually, bit by bit, some of the other modules in the legacy will have become tested. And then at some moment, you will look at this code and say, you know what? I think we can pull out all this tested stuff and surround all the untested stuff and strangle it out of existence. Rewrite it until it doesn't exist anymore. Hopefully you've got the that central part small enough by that time. That's not necessarily good news. If you've got a legacy environment, you're stuck with a mess for a long time. It took a long time to make the mess. It's going to take a long time to clean it up. There's no magic bullet there. But don't make the mess worse. Don't continue to propagate the problem. Start gradually to clean it. Has anybody read Michael Feather's book on this topic, Working Effectively with Legacy Code? Oh, Working Effectively with Legacy Code. Let me get that. Share my screen and I'll show you that book. Can you see my screen still?
I have it.
Well, you haven't read it. Just for on yours. Yeah.
Can you see my screen?
Yeah.
Okay. There's the book, Working Effectively with Legacy Code, Michael Feathers. This will be the most depressing book you will read. It's Full of lots of really great ideas and lots of clever ways to help you get the system under test, but it'll also make it very clear that it is not an easy task. There's no simple solution. Anybody else with a question? Looks like no more questions. Oh, I see you. Go ahead.
How do you suggest, I mean, this is a naive question we all want to do, and how did you sort of force yourself to get in the mindset of doing it and not getting pressured by getting it done in a certain time frame on a certain amount of money?
Yeah. I took it as a discipline. I said to myself, you know, I've been programming for a very, very long time. I'm 62 years old. I wrote my first program when I was 12. So I've been programming for a half a century. And at some point in roughly 1999, I saw this discipline for the first time. Kent Beck showed it to me. I never thought that someone would show me a new way to write software. It didn't occur to me that there could be a different mechanism for writing software. And I was completely floored when I saw this. And I sat with Kent Beck for a day and wrote code with him and using this style. And I came away from that experience thinking, well, for the last 30 years I've been doing something that didn't work all that well. I'm going to try something different. And I just determined I was going to do it. And I'm very glad I did because it's made things so much simpler, so much easier to get good software written quickly. That's kind of the issue, right? You make a decision. I'm not going to make the problem worse anymore. I'm going to make the situation better. I'm going to do that by writing tests. I know that's going to be challenged by people who are worried about schedule, but I am convinced that this is the only way I can go fast. There's a little bit inside your head, and this little bit, it's a binary bit, and if it's a 0, you believe that writing tests will make you go slower, and if it's a 1, you believe that writing tests will make you go faster. If you flip that bit to a 1, no one can stop you from writing tests. If that bit is a 0, you aren't going to write tests, period. So you have to flip that bit. You will go faster if you follow the discipline. I do. You should try it. Flip that bit if you can. Anybody else?
What do you think about using TDD without, well, let's say you're not in a project or a team that uses Agile, would you still be able to incorporate TDD in your daily routine?
Sure. Test-driven development is a personal discipline. You do it for yourself. It doesn't matter if you're in an Agile team or not. It doesn't matter if the project is Agile. Now, what does matter is if other people on the team are not doing test-driven development and then they start messing with the code you wrote. And they don't write tests, and they screw you by not writing tests. If that happens too many times, you're going to wind up having a divorce. There's no way you can survive in a team where half the people are doing tests and half are not. So you wind up splitting the team in half or quitting or something like that. Once it has become a personal discipline, you're going to do it. And you're just going to keep doing it. And then everybody who doesn't do it, you have to keep away from your code. Those people who are doing it, you let them in. They can touch your code all they want because they're going to be writing tests, right? It's not your code. It's the team's code. The whole team can play with the code and improve it. But the guy who doesn't write tests, he can't be on that team.
Do you think that's the reason why maybe TDD isn't as prevalent as it should be because there's a lot of legacy code and there's a lot of people who don't do TDD and reasons like that.
I think that's part of the reason. It's hard because most people are in legacy environments, so that makes it very difficult. It's hard because most people are in teams where there are folks that are not writing tests. Test-driven development is not as prevalent as it should be, but it is much more prevalent than it has been. If I had asked a group of people 5 years ago how many of them were doing test-driven development, I would have seen maybe 2 or 3%. Nowadays, I see close to 20%. The numbers are increasing dramatically. And the reason the numbers are increasing dramatically is that nowadays there are whole companies that are doing test-driven development. All the programmers who adopted the discipline left wherever they were and they moved to companies where it's being done. So there's this massive reshuffling of people. The test-driven developers are going to the companies where it's done, and that's causing this division. There are companies who do it and companies who don't, and that will probably continue. Eventually, we'll wind up with a bunch of companies that do and a bunch of companies that don't, and the companies that don't will fail and die. And then everybody will do it.
Another quick question. Have you ever had a boss or a manager, maybe when you're first getting started in test-driven development, and trying to get this concept across to them or to explain to them that it will make things better in the long run, even if there's more upfront costs? Have you ever had to deal with that, and if so, how did you deal with it?
So, what business is it of the bosses whether you write tests or not? You're the programmer. You're the one who knows. What business is it of your boss? And that's the first question to deal with here. Yeah. Of course, I've seen bosses do this. I've seen managers come in and say, "What are you guys doing? Why are you writing tests? We're too busy. Just forget all the tests." It's none of the manager's business. Manager doesn't tell you when to write if statements, doesn't tell you when to write while loops, doesn't tell you where to put your semicolons, or if he does, he or she is just the wrong kind of manager in general. This is a personal decision that you make. It's a professional discipline. You decide to adopt it, and you don't ask for permission to do that, and you don't tell your boss you're doing it. Oh, by the way, I'm going to be writing tests from now on. You don't say things like that. You just do it. I presume you don't ask your boss if you can wash your hands after going to the bathroom, and you probably don't want to ask your boss if you can write tests. Right? Same kind of personal issue. Never forget why you were hired. You may think you were hired because you know how to code. That is incorrect. You were hired because you know how to build software systems. And the responsibility of someone who knows is the responsibility to say no when no is the answer. You were hired for your ability to say no when no is the right answer. What happened to healthcare.gov? October 1st, 2013. They were supposed to turn it on. They did turn it on. Why did they turn it on? It was a disaster. The disaster nearly derailed a law that was passed by Congress and signed into law by the President of the United States, and a software failure nearly derailed it. Why did they turn it on? Do you think there was some programmer in there somewhere who said, you probably shouldn't turn this on? You think there were maybe a lot of them who knew that? Where were they? Why didn't they speak up? Actually, they did. Quite a few of them spoke up. The word train wreck was bandied about quite a bit by the technical staff, and yet they turned it on. How did that happen? You were hired. You were hired for your ability to say no. Your success will depend to a large extent on how well you are able to enforce no when no is the right answer.
Now, do you, I think it was you that wrote in a blog about the Challenger. No, it was a book.
Yeah.
It was your book, the Challenger disaster.
Yeah.
How the engineers fought and went through all the proper channels, and then still they were told, no, we're going to launch, and it cost the lives of those astronauts. You know, what do you do in situations where you've gone through the proper channels and, you know, like in healthcare.gov, and still they say, well, we're just going to do it? What do you do then? Do you just
This is a deeply ethical issue because you're finally at the position where you're going to be a whistleblower, you're going to lose your job, you're going to have a lousy reputation, and it's the right thing to do. Those engineers at Morton Thiokol who knew the risks of launching the Challenger, who knew those O-rings couldn't stand the temperature, who wrote memos with big red flags on them saying, you can't launch this thing, who walked out of the room when the launch was televised because they didn't want to watch it blow up, those engineers didn't do one thing. They didn't call Dan Rather.
Right.
And if a Morton Thiokol engineer had called Dan Rather and said, this thing can't launch, it's going to blow up, that guy would have lost his job, he would have been completely discredited, and there would be 5 living astronauts today. I'd hate to be those guys. I'd hate to be those Thiokol engineers. I'd wake up in cold sweats every night thinking, why the hell didn't I call Dan Rather? There you go. Big ethical problem. Welcome to the world of being a professional. And with that, silence. I think I shall bid you all adieu. Thank you for inviting me into your conference room. This has been a lot of fun. And
thank you so
I
much.
hope I can see you all later.
Before you go, Bob, do you have any resources on test-driven development that you could maybe share with the group if anyone's interested in any further reading or?
Lots of reading. There's a ton of books on the topic. There's a lot of articles too. So there's 2 books whose title begins with test-driven development. One of them was written by Kent Beck. It's excellent. The other one was written by Dave Estells. It is also excellent. I've done an awful lot of articles on the topic. There's lots of other blogs and things like that. If you follow J.B. Rainsberger, he does a long blog on all kinds of, a serial blog on all kinds of test-driven development issues. There's another one by James Shore. He's done hundreds of blog episodes on test-driven development. The resources out there are enormous. And then, of course, I'll show you I'll plug my website. See if I can get this thing here, if I can figure out how to do this. Okay. I should be able to share my screen and take you to cleancoders.com, where there are tons and tons of videos, and many of them involve test-driven development. There's a whole series here on advanced test-driven development, which talks all about all kinds of different stuff that you can learn about test-driven development, mocking and the test process and test patterns and how to write clean tests and all this stuff. And there's plenty of other stuff on these videos as well. So that's my plug.
Do you partner with Pluralsight at all?
I do not. These videos are sold on my website.
Gotcha.
Yeah.
Does anyone have any other questions? Well, thank you again. It was a blast having you.
Yes.
We should we'd love to have you again sometime in the future, if your
Sure.
schedule permits.
Sure.
Sure, love to.
Sure.
Well, thanks again.
Thank
you.
Talk to you later.
Thank you.
Bye.
Bye.